chapter 1, section 1. Apply properties of real numbers. All right, so the first thing we're going to do is we're going to do some definitions. All right, we're in math class, so we'll be speaking some math. The first definition, the counting numbers. The counting numbers. Sometimes people call these the natural numbers. I write in all caps and I like to abbreviate. So if you don't know what something means, you just have to say, hey, Mercedes, what does that mean? What is that? What does that say? All right? So the counting numbers are the natural numbers. Y'all listen to me. This is so easy. These are the numbers that you naturally start counting with. Okay? Like if I went up to a first grader and I said, Johnny, can you count to 10? Would he say 0? No, he's not going to say 0. He's going to start and he's going to go 1, 2, 2 and a half, 2 3/4. No, that's what your mama does when she's giving you time to do what she already told you to do, right? Okay, so those the numbers you naturally count with, those are the counting numbers. So the numbers you naturally start counting with. All right, and they are going to be 1, 2, 3, and on like that. All right, the next one, whole numbers. Whole numbers. Okay, so my sister and I already told you we're all like math people at where I came from. My whole family was math people, and my sister and I, we make up all these stupid ways to remember stuff, okay? Because it's easy for us to remember stupid stuff, but when it comes to really important stuff we need to remember, we all have a hard time with it. All right, so look at this, whole number. When I say whole, what letter of the alphabet does it sound like? Yeah, O. Sounds like whole, O. What number looks like an O?
0.
There they are, whole numbers, 0, 1, 2, 3, 4. I'm just adding to it, okay? 0, 1, 2, 3, and on like that. Okay? Now here's why these are important, because sometimes you'll have a reading problem, and the reading problem might be, tell me the two integers that blah, 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 blah. Okay? Let's say you worked the problem and you got 2.5 as your answer. What would you know?
It's not a whole number.
No? Is it an integer?
No. But yes?
Yeah? So, no, sorry, Charlie, no, it's not. You were right. I don't know what I was thinking. So, no, it's not. So, if you got 2.5, you would know that your answer was wrong, right? You'd be like, oh, crud, I messed up somewhere. You see what I'm saying? So, they're like giving you hints, and you got to know the definitions to be able to do it. All right, so integers. Okay, integers are simply whole numbers and their opposites. Whole numbers and their opposites. All right, so you're going to do whole numbers 0, 1, 2, 3, and on. And what are their opposites?
-1.
Yeah, -1, -2, -3, and they go on in that direction. Okay, so tell me what integers are not. What can they not be?
2.5.
Because that's a what? Decimal. And what else can they not be?
Fractions.
Fractions. Okay, so listen to me. Watch one. This is one of my note-taking skills. Okay, pick your favorite color pen. All right, mine's pink. So every time I see something pink, it's either going to be on the test, because the teacher said you might see this again, all right? Or it's maybe a shortened version or a different version of the definition. So like on this one right here, what I'm gonna do is I'm gonna say, hey, this is no decimals and no fractions. So what happens when I'm looking back through my notebook really quick, then I don't have to read all this stuff right here. I just go integers. Oh yeah, no decimals, no fractions. I remember that. You see what I'm saying? All right, the next one, rational numbers. rational numbers. All right, I'm gonna put the technical definition of a rational number, because that's what you would find in a textbook, a math textbook, because they're written with technical. They're called a technical book. All right, so any number that can be, didn't say it had to be, but can be written in the form A over B, where A and B are integers, and B cannot be equal to 0, because division by 0 is not defined. Okay, so B can't be equal to 0. All right, so I love this definition, because this definition right here tells me what's legal and what's not legal. All right, it says that the number on the top and the number on the bottom have to be integers. That right there says you can never, ever, ever have a fraction within a fraction. You can't put 1/2 over 4. You can't put 2/3 over 1/5. Okay, that's not legal. You can't put a decimal in a fraction. You can't put 2.3 over 6. All right? Fractions within fractions and decimals within fractions are not legal. They'll both be counted wrong. All right? So, answer this question. 4. Is that a rational number?
Yes.
Why?
You put it from here.
I can put it as an, yeah, how can I write it? 4 over 1. So 4 is a rational number. What about 0.25?
No.
Yes.
Yes? Why? 1/4. It's a quarter, people. It's a quarter. Listen, there's 2 things kids know about: money and food. Okay? A quarter. What part of a dollar is that?
25 cents.
That's how much. That's what it's equivalent to. What part of a dollar is it?
Fourth.
1/4, right? A quarter. 1 out of 4 quarters makes a dollar. All right. So 1/4. So this is 1/4. 0.25 is 1/4. What about 0.3333 repeating?
No.
Yes, why?
1/3.
Oh, that's 1/3. Oh, okay. So really, what is this really saying? If you can do what? That's exactly right. So this is really any number that can be written as a fraction. Any number that can be written as a fraction. Do you see how much easier that is for my brain to say, oh, okay, now I know what you're talking about. If I can write this number as a fraction, it's a rational number. If I can't, it's not. Okay? What about this number? The square root of 7. Let me show you what it is. The square root of 7. It says 2.645751311. Does it really stop there? No, it really doesn't stop there. It keeps going on forever and ever and ever. Can I write it as a fraction? No. You can't. He's not rational, guys. Okay? He's not rational. So what about this one?
Yeah. Yes.
Oh, why? So why did I put this one after I did this one? Because what do people's brains say? When I say the square root of 7 and I say it's not rational, what is some people's brains telling them the reason it's not rational? Yeah, if it's got a square root, it's not rational. That's not true, people. If you're taking the square root of a non-perfect square, then it's not rational. Okay? But 9's a perfect square, right? What is the square root of 9? 3. Can you write that as a fraction?
Yeah.
3 over 1. So that is rational. Okay? All right, so those are all rational numbers. Any number that you can write as a fraction is a rational number. So here's the last ones. Irrational. Irrational number. Okay, an irrational number is a non-repeating, non-terminating, what does non-repeating mean?
It doesn't repeat.
Yeah, it doesn't repeat. Like, see this guy right here? He repeats, doesn't he? Okay? He's not irrational, he's rational. Okay? So it can't repeat. Non-terminating. What does that mean? It doesn't what? Yeah, it doesn't ever stop, it never ends. Non-terminating decimal. Alright? So I got a decimal and it doesn't repeat and it doesn't stop. Like this guy right here, right? Okay, so tell me one that you all know.
Pi.
Pi. Pi is an irrational number. What about square root of 7? Yeah? Y'all, if you take the square root of a non-perfect square, it will always be irrational. Okay? The square root of a non-perfect square will always be irrational. So if I asked you to name 40 irrational numbers, could you name them really quick? The square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 7, the square root of 8, 9, the square root of 10, the square root of 11, the square root of 12. You see what I'm saying? Then you just go down the line. I got this. Okay? It's not hard. If you take the square root of a non-perfect square, it is an irrational number. Okay, what about this number? 0.1, 2, 3, 4, 6, 7, 8, 9, 10, 11, and on.
If it's
Yeah.
never ending, it's zero.
No, it can't just be never ending, it can't repeat. No repeating and no ending.
That's all right, it won't repeat.
No, it won't repeat.
If you're counting, it doesn't repeat, so you're not gonna count it.
That's exactly right. So that is irrational. What about this guy? 0.12112.
No.
That's a pattern.
Is there a difference between a pattern and repeating? Yes, there is, because watch, here's what someone's gonna say. They're gonna say, okay, I don't know, does this thing repeat? 1, 2, 1, 2, no, oh, you have to go 1, 2, 1. 1, 2, 1, 1, 2, 1, 1, 2, Maybe you go 1, 2, 1, 1. 1, 2, 1, 1, 1, 2. You see what I'm saying? It doesn't repeat. There's no set digits. Like, look at this. What about this number right here? 0.135, 135, 135, 135. Yeah, that repeats. What does it repeat? 135, 135, 135. You see what I'm saying? This does not repeat. It uses the same 2 digits all the time, but there's 1 1 and then 2 1s and then 3 1s and 4 1s and 5 1s and then 6 1s and a 2 and 7 1s and a 2.
How does the two not repeat?
No, it can't just be, like, you can't say, okay, you can't say, if I use a 2, it repeats, because, if you're counting, haven't I already used a 1? You see what I'm saying? I mean, there's only 10 digits, a 0 and then 1 through 9, all right? You're gonna have to repeat them, but just not in the same order. See what I'm saying? Just like pi, okay? All right, so this one is not. He repeats, so he's out. All right, have you ever heard of a Venn diagram? Yes, we're gonna make a Venn diagram, and it's gonna contain all this information right here. Sometimes people see it better in a Venn diagram, plus a lot of times, math and science people use them, so I think it's good for us to go over them every once in a while. All right, so I'm gonna make a big long rectangle, all right? Now look, I'm gonna divide a little piece out, because this part right here, I'm gonna tell you what they are, but we're not gonna study them until after Christmas, all right? So over here on the left-hand side, where the big section of the rectangle is, these are my real numbers. That's what we're gonna talk about, okay? Real numbers. We're gonna talk about these up until after Christmas. And then over here, if it's not a real number, does anybody know what it is?
Irrational.
Not real.
Yep, not fake. We don't call them not real, we don't call them fake, we don't call them faux.
Irregular.
Imaginary. Okay, you'll know them because they have a little cursive I behind them. Okay? Imaginary numbers. See, there was a problem one time and a math person couldn't solve it and they had to develop a whole system of numbers called imaginary numbers so that they could work that problem. Pretty cool. Alright, so we're only talking about real numbers. Real numbers are divided up into two parts, like Charlie was saying. Okay? And the biggest part of them, we're going to make it rational because I need more room to draw. So these are the rational numbers, and these are the irrational numbers. Okay? Tell me an irrational number.
Square root of 7.
Square root of 7. Tell me one that's not on the paper. The square root of 5. Okay? Tell me another one.
Pi.
What's the one that you learn like in junior high? That you use a lot?
One.
Pi? Let's put him in there. Okay, we're going to learn another one this year. I'm not going to write it down. But, and it's an E. It's a little E. It looks like this.
Type that in your calculator after a bunch of numbers.
Yes, you can. It is on your calculator. Okay? It's named after this guy. I can't say his name without having some kind of northern Yankee accent. So I'll tell you, it's Euler. Euler's number. That's what this is. And Euler is spelled like Euler. E-U-L-E-R. So that's why the E's there. Okay? So anyway, he's got one. What about this one? 0.1234. Right? Okay, now let's do rational numbers. Okay, so here's what I want to do over here. I want to make a circle about this big, so I have enough room to write in it. And then I want to make another circle around it. And then I want to make another circle around it.
Excuse me, teacher, pardon the interruption. This is messages for you students who are bus riders for this afternoon. Just a reminder, if you have not filled out the bus rider information sheet with transportation, you will not be allowed to board the bus this afternoon. So if your parents dropped you off this morning or you caught a ride to school and you did not fill out the transportation request, then you're going to need to find a ride home and then get that form filled out ASAP. Also, another question that's floating around is about advisory. And yes, you have an advisory that you need to go to. You will be counted present or absent, skipping class, just like any other. It's just a class, guys. So, yes, you have to go to your advisory. Yes, you have to be on time. Yes, you'll get marked tardy. Yes, you'll get marked absent. So, figure out who your advisory teacher is and make sure you're there on time. Thanks, guys.
Okay, so advisory is going to be a nice place, but you have to have, like I don't think they're doing it today, but like if you wanted to come in here and ask a question, get some help or something like that, you know, then you have to have a note from me. Like we have a note, I'm not going to fill it out because advisory is not going to be more work for me. I'll give you the note, you fill it out, and then I have to sign it, okay? And then what's going to happen is you're going to take it to your advisory teacher. And then if you don't show, I'll write your name on my board. And if you don't show back up at my class because you skipped out, then I will turn you into the office. Okay? So be careful. Don't think you're smarter than a bunch of teachers. All right? Don't think, oh, I'm going to get my note, show it there, and then I'm going to get me a cup of coffee at the Jumping Bee. No, people, no. We'll be in trouble. All right? You don't want that. All right. So everybody right here. Okay, so in the innermost circle, these are my counting numbers or my natural numbers. We don't get out of here till 3, okay? I know you feel like you've been in here forever and a year, but we still got 30 more minutes. So, counting numbers or natural numbers? Tell me what they are.
1, 2, 3.
Very good. 1, 2, 3, 4, 5. All right? And right outside the counting numbers are the whole numbers. Now, what is the, what is the only whole number that's not a counting number? 0. So all I have to put out here is 0 because it is 0 and all these others in the circle. Okay, so is every counting number a whole number? Yes, he's in their circle. Do you see what I'm saying? The counting numbers are inside the whole circle. So the counting numbers, every counting number is a whole number. Is every whole number a counting number? No. See, 0 is not in his circle. So 0 is not a counting number. That's the way you read a Venn diagram. Okay? And then outside here we have integers. Now, obviously, integers are whole numbers and counting numbers. Okay, counting numbers, whole numbers, and what else? They're opposites. So what are the only numbers that we haven't listed? Yeah, the negatives. So I'm going to say -1, -2, -3, and they keep going that way. And they keep going this way, all right? But those are all listed right here. So I have to rewrite them. Okay, so what am I going to write out here? I'm going to write, now are all these numbers rational numbers? Yes, they're in their box, so they have to be. So tell me a rational number that is not an integer. What? Say it. Come on, be brave. 0.3. Can I write this a fraction? 3/10, people. 3/10. Remember, this is tenths, hundreds, thousands, 10,000s, 100,000s, millions. Okay? So, 3/10. Tell me another one.
If 0.5 is on there, would that consider half?
Yes, 0.5. That's 5/10, which reduces down to 1/2. You see how it makes sense? Like the 0.25, that was 25 over 100. Because it was, the 5 was in the hundreds place. And that reduces down to 1/4. Okay, what about 2/3? Is that good? Okay, so everybody got the gist of it. All right, so let's do a problem. Are you ready? Oh, that's the third time I've done that. I try to lick my finger and then I lick this mask. Stupid. You're not supposed to be licking your fingers anyway. So. All right, so here's our problem. Now, this is, if you had a book and you were looking at it, this would be example 2 in section 1, okay? And, here's what it says. List the numbers from least to greatest. Okay, y'all listen to me. This is, you're gonna have questions like this on your test. Should you be able to list numbers from least to greatest? Okay, so first of all, I just told you something. Where did I say you were gonna see this? Okay, so right now, I'm like taking my favorite color, I'm starring this, and I'm going, oh baby, this is on the test, okay? This is on the test, you better know how to do this, all right? And now, the next thing I'm gonna do is I'm going to tell you, okay, so like at my mom's old house, there's a big long driveway. Right when you back out of the driveway, there's a telephone pole across the street, right in the middle. So what happens if you're not paying attention? You hit it. So wouldn't it be nice of me if I said, you came and visited and I said, hey, be careful when you're backing out, because there's a telephone pole directly across the street from Mom's driveway. So that way you won't back into it. That would be nice, right? Yeah. Okay, so if I told you what the most common mistakes on these type of problems are on the test, that would be good, right? To help you not make those mistakes, okay? So one of the most common mistakes is, instead of from least to greatest, what did they do? So, I mean, I don't know which way it's gonna tell you to do it, but inevitably, somebody's gonna not be paying attention and just do it however they want to, okay? That was Tana, all right? There's my 3 kids. See those 3 kids over there? I mean, they're all grown up now. But see them all acting like they like each other, see? Okay, so the oldest one is in the middle, that's Katie. That's her in her wedding dress. She's the only one that's married. She's married and has 2 little kids. Grayson is 2.5 and Sophie is 1. Miss Sophie is a mess. So they just got back from a vacation kind of with her husband's family. And she said she was pretty sure Sophie wasn't invited back next year, cause she acted like a Hank. But, so that's Katie, she's a teacher, alright? And then Becky is the middle one, she's on the far right side. They all went to school here, they all had me. Did they all make A's? Oh, no, Katie doesn't care any, I mean, if she makes an A, great, if she doesn't, she makes a B, that's okay. I mean, she's not gonna make below a B, but she didn't need to make it, I mean, you know, she was like, if I can just do a little and make a B, I'm okay with that. Now Becky has to make an A. If she doesn't make an A, she's beside herself and terribly in a mess, okay? She's a nurse at St. Eve's in Beaumont. She lives here, but she lives in, I don't know, I guess she lives in Orange, but it's not around us, but, so she's a nurse. And then there's Tanner. Oh, Lord, help us all. There's Tanner, he's the baby. He's the, finally got him out of high school, and lots of prayers. He'll be finished with college in May. He should have graduated this past May, but, he messed around and played around and like had to take speech 3 times. And then we kept telling him at some point, this is gonna cost you, you know, it's gonna cost you big. I just need to take the class again. I just need to take the class again. So then when he thought he could graduate in December, only 3 of his classes were offered in the fall, and 2 of his classes, he likes 5 classes. 3 were offered in the fall, and 2 were offered in the spring, so it's gonna take him a whole year to get 5 classes. So, you know, Ron said, that's what happens when you goof off and mess around and don't take care of your business.
What college is he going to?
He is at Texas State. He will have his mechanical engineering degree. So, he's a smart kid, but he's a whole lot about having friends and having fun. So, he's only in the last year or 2 decided that school and grades are important if you want to have the things that he wants to have when he gets out. Because mom and dad are through. So, alright, he was the one that did his from greatest to least and then wanted partial credit for it. I was like, no, I'm pretty sure none of it's right. And, well, I'll put them in order. Oh, well, good for you. You'll just need to follow directions next time. Okay? So, whenever I read my directions to keep me from making mistakes like that, I'll write something like, start small. Okay? Start small. If it says put it from greatest to least, then I'll put start big. Okay? Start at the largest or something like that. The next common mistake on these kind of problems is you must write as is. Okay? You must write it as it's given. So, here are the numbers, and we are going to put from least to greatest. -5, 47/5. -5, 47/5. The square root of 32. -1.27. And negative the square root of 8. Okay, now guys, I'm going to give you a calculator on the test, okay? If I give you on the calculator on the test, do you have any reason to miss this?
No.
There's going to be 3 to 5 people in this class, and you will miss more than one of these. Is that crazy? Y'all, that's crazy. This is like a 6th and 7th grade deal, okay? So, the first thing I would do is I would use my calculator and I would figure out what the decimal equivalents to some of these are. So, I mean, you can either say 5 goes into 47 9 times with 2 left over, so that's 9 2/5. Or you can say 47 divided by 5 and say that's 9.4. Okay? The square root of 32. Do you agree that the square root of 32 is between what 2 perfect squares? 36 and 25. So that means the square root of 32 is between 5 and 6. Do you agree? Is he closer to 5 or closer to 6?
5.
I don't know. I'm asking.
6.
Why? Yeah, because 32 is how many away from 36? 4. And he's 7 away from 25. Okay? So this number is going to be 5 point something, but it's going to be closer to 6, so it's going to be more than 5.5. You see what I'm saying? All right, so even if I didn't have a calculator, I can still get pretty close with this. But we'll just say the square root of 32. And there it is, 5.66. All right, and then negative square root of 8. Negative 2.83. Now these are just approximations, okay? So now I'll look at it and I'll start small, What's my smallest guy? Negative 5. So I'm gonna write negative 5 down and then we'll mark him out. I don't wanna, y'all, if I've used him, he's out of the game. Okay? Now, what's the next smallest? Negative 2.83. What do we have to write down? Negative square root of 8. That's what I mean by write as is. Were you given negative 2.83? No, so don't write it. People, what are you talking about? There is no negative 2.83 in this problem. You see what I'm saying? Okay, so now he's out. What comes next? Negative 1.27. Mark him out. What comes next? Square root of 32. So right there, you just learned that I learned from my first mistake. Okay? So if you wrote negative 2.83 and then you wrote 5.66, you didn't learn. All right, so he's out, and what goes next? 47 over 5. And some of you said, yes, I finally learned. All right, so anybody got a question? People going to be on your test, going to be on your worksheet. All right, going to be on your test and going to be on your worksheet. All right, so now we're going to make a table out. Okay, a table. And over here we're going to have 3 columns, but this one I'm going to make it the fattest. So, and he is the column that's going to name the property. I don't know why that looks weird, but whatever. The middle column is going to be the property of addition, and the last column is going to be the property of multiplication. All right, and what are these? These are properties of real numbers, addition, and multiplication. Okay, properties of real numbers, addition, and multiplication. Now, here's something important. I'm going to star it, put it in pink. There are 6 problems like this on the test. 6 problems like this on the test. I'm going to tell you what the property is. I'm going to show it to you. I'm even going to tell you an easy way. We're going to figure out easy ways to define the property. Okay? There are only 1, 2, 3, 4, 5, 6 properties. Okay? 1/3 of the class will miss 4 or more. That's a lot, people. That's a whole lot of giving away stuff. All right? Most of the reason that you will miss is because you won't study it. I'll say, don't forget to go back and study the properties, but a whole bunch of you will be like, oh man, I forgot to study the properties. Okay? So as we go through the properties, see if you can get them and learn them. We won't have any time to do examples today, but we will tomorrow. We'll pick our Wednesday. We'll pick right back up. Okay, so the first property that we're going to talk about is closure. Closure. The property of closure. The addition property of closure says if you add 2 real numbers, you're going to get a real number. So A plus B, I add any 2 real numbers. It is a real number. Multiplication says I multiply 2 real numbers. A times B is a real number. So real numbers are closed under the addition property and the multiplication property. If you add or multiply real numbers, you will get a real number. Now, are you listening to me? Everybody listening?
Yes.
We never use that property. Okay? We never use that property. So I'm giving you 6 properties. What did I just do with that? I knocked it down to 5, people. Okay? If you're going to guess one, are you going to guess closure? People, I just said we never use this property. okay? It is not an answer on the test or the worksheet. We don't use it, all right? Okay, here's the next one. Commutative property, Commutative. It's abbreviated COMM. Okay, it's really commutative, but down here, we don't enunciate stuff very well, okay? We're just worried about saying it as fast as we can. All right, here's what the commutative property of addition looks like. A plus B is equal to B plus A. You see it? 2 plus 3 is equal to 3 plus 2. Okay? That's the commutative property. Multiplication. A times B is equal to what? B times A. What about subtraction? Is subtraction commutative? No. 3 minus 2 is 1, but 2 minus 3 is negative 1. Do you see what I'm saying? Not everything holds true for that. All right? So, tell me when you look at these things like this, tell me a word that comes to mind that would be easy for us to switch. What's another one? Flip. Flip, flop. Okay? Or some kids like the word mirror. Now look, here's what I would do, guys. I would pick one of these words and I would write one word down. Whichever word comes to mind when you look at this. You see how they flipped? How they switched places? Or how they mirrored each other? Alright? Pick you one. Now when I look at this is what I'm looking for. Did those things switch? Did they flip? Did they mirror? Whatever word you like. Does everybody understand? Okay, here's the next one. Associative. Associative. And you have to put more than ASS to abbreviate. Okay? ASSOC is how we abbreviate it. And this is what it looks like. Now, know this. If I say the word quantity, it means that I want you to put parentheses around it because I want you to do it first. Okay? So, the quantity A plus B plus C is equal to A plus the quantity B plus C. Multiplication is going to look exactly the same, except instead of plus signs, what am I going to have? Yeah, a dot for multiplication. So he's going to be the quantity A times B times C is equal to A times the quantity B times C. Okay, so let's talk about maybe something to help me remember associative. First of all, when I look at these, how many things do they have? 3. They each had 3 things. That's very important. If it has 3 things, my brain starts screaming, it's the associative property, it's the associative property, okay? But then I have to check one more thing. What happens from this side to this side? What stays the same?
The parentheses move.
No, well, what stays the same?
The middle.
Look at this.
The order.
A, yep, B, C. A, B, C. Over here, A, B, C, A, B, C. So you have to have 3 things, but what do they have to keep?
The order.
Yeah, they have to keep the order. If they don't keep the order, it's not the associative property, okay? It has to keep the order. So 3 things keep the order, that's the associative. A commutative is your switch, flip, mirror, whatever you want to call it. All right, 2 more and then we're going to probably stop because that's where we got to in the other class. Identity. Now, I'm going to tell you this. These last 2, kids mix these last 2 up all the time, okay? So let's talk about identity first. All right, now in this we're going to learn some new stuff, but it's stuff you already know, but maybe you just hadn't heard the name of it before. All right, so let's say I have any number in the world. I'll call it A. I'm doing the addition one, okay? What can I add to A and it not change?
0.
0. Okay? and then it keeps its identity. You see that? It keeps its identity. So guess what? This right here, this is called the identity element of addition. 0 is the identity element of addition. Why? Because I can add 0 to everything in the world and it keeps its identity. Okay? Now-
times anything by one.
Yes, yes. So over here on the multiplication one, we're gonna say any number times 1 is that number. It keeps its identity. So what's the identity element of multiplication? 1. Okay, so y'all look, this is the easiest way for me to show you how not to get these two confused. I'm gonna write another one down here. As soon as I write it down, you'll go, oh, that's one thing that's confusing. But y'all listen to me. If it's the identity property, it has to keep its identity. It was an A. Did it keep its identity?
Yes.
Yes, it is an A. It was an A. Did it keep its identity? Yes. Okay? If I said 10 times 1 equals 10, did it keep its identity? Then that would be the identity property of multiplication. You see what I'm saying? Okay, so here's the other one. The one, let's write that down. Keeps identity. Okay? Keeps his identity. All right. So here's the one they get it mixed up with. Inverse. Now, what's the first thing that you see?
I.
Yeah, they both start with an I. So that right off the bat, your brain's going, whoa, wait a minute. I got 2 I's here. All right? So, inverse. Now, here's the inverse property of addition. I have a number. What can I add to that number and get the identity element of addition? So what I want to do is I want to get 0. What is the inverse of A? Negative A. Okay? Over here, A times. What can I multiply by A and get 1? Well, we struggled last period to pull this one out of the kids. Okay? What number a number times its blank is always equal to 1.
Opposite. Just because you use a
It's
negative
a-
number and divide.
Mm.
I remember this, I remember this.
It's what?
It's
I can't understand what you're saying.
8 times A would be 1.
No, A times A is A squared.
I remember this from his vision class, that's not pulling out.
Yeah,
Yeah.
yep. Okay, so 3, what would you multiply 3 by to get 1?
One only divide.
But we can't divide, so what do you have to multiply by?
Negative I.
No, not a negative, y'all. And positive times a negative is gonna give you a negative number, okay? It's what, it has a relationship to this number right here. 3 times what is 1? What's his? Not his opposite. His opposite is, I know it's like, oh, starts with an R. Mr. Ryan said it starts with an R. C. Yes, say it. Reciprocal. Yes, it's reciprocal. What is the reciprocal of A? Yeah, you put it over 1 over that number. What's the reciprocal of 3? 1/3. What's the reciprocal of 4? 1/4. Watch this. What's the reciprocal of 2/3? 3/2, right? Guess what 1 over 2/3 is? 3/2. 1 over any number is his reciprocals, okay? And any number times his reciprocal is 1. All right? There's another word for this. It's the most fun word in the whole wide world to say. Not reciprocal, but multiplicative inverse.
I'm not saying that.
Multiplicative inverse,
I'm not
okay?
saying that, that's fine.
Multiplicative inverse. Alright, so this is the multiplicative inverse. Alright, now listen to me, guys. This is what I don't understand. In order for it to be the identity property, it has to keep its identity, right? Did he keep his identity?
No.
Then why would you put identity? You see what I'm saying? Did he keep his identity? No. Okay? So, inverse property, what does he do? He gets the identity
Someone else.
element. Okay? He gets the identity element. So this one keeps its identity, and this one gets the identity element. Alright, we have one more that we're going to do, and then we'll work some problems. And then we'll finish up this section and start on the next section. Here's the one thing I want to make sure that you understand, because y'all have never done block scheduling before, okay? Have y'all? Oh, okay. Yeah, y'all did, didn't y'all? Yeah, but we didn't do half a day. Okay, so on a block schedule, one day is really 2 days. Okay, so normally while we do one section a day, we're looking to push 2 sections a day. Okay, now it depends upon the section, all right? But if the section is supposed to be covered in a 45 to 50 minute class, then we should be able to cover two of those in an hour and a half class, all right? But you only see the teachers every other day. All right, y'all have a good, y'all got one more class, don't skip out on it. Or get in trouble, you ready for